Okay, so let's talk about Descartes' rule of sign. René Descartes was also a famous philosopher. Please don't say Descartes. The S is silent. It's René Descartes. And basically what he discovered to be true, no matter what, is that just given any polynomial, every time the sign switches from a plus to a negative, he can figure out how many possible zeros there are based on that sign. The same is going to hold true when we plug in a negative or an opposite value. We're going to analyze the sign switches and we're going to come up with a possible number of a negative 0 or a positive 0. Whoops, let me straighten this. I'm so sorry. Let me show you what we're talking about in this example. A variation in sign means two consecutive coefficients have opposite signs. Guys, basically it's a switch from this to this or from this to this. Pretty easy. All right, here we go. Let's use René Descartes' rule of sign to find the possible number of positive and negative zeros of this polynomial. So if you analyze what's going on right now, this is positive. Oh, look, that's a switch. It turned from positive to negative. Here's another switch. This is negative, switch to positive. It's positive here, it's positive there, so that's not a switch. But here's a switch from positive to negative. So how many times did the polynomial change signs? 3 times. 3 times it changed. Okay, so the polynomial has 3 variations in signs. So what that means is you can have up to 3 positive values or you always decrease it by 2. I'm going to ask you that question, so make sure you understand what I mean. When you find the highest possible value of positive answers, positive values, you always decrease that by what? 2. And that's going to give you your other possibility. 3 minus 2 is 1. Positive 0. I'm going to start calling this a 0. Remember that zeros are answers to an equation. All right, so now let's plug in negative x. When we plug in negative x, remember what we talked about right here. That's why we talked about it. This is not going to be too tough. When we plug this in, look, that's an even value. When I plug in a negative x, remember that even value is going to stay exactly the same. Look, here's an odd exponent. Remember when you plug in a negative with an odd exponent, the sign changes. So we're going to write plus 17x to the third. Here's an even exponent. I'm just going to copy exactly what it was for the original. That sign is not going to change. Look, here's an odd. So if it's an odd, the sign is going to change. Let me recopy the minus 45 because that might affect our changes. Okay, so let's analyze the changes when we plugged in the opposite value. Don't look at your previous line. Let's just focus on the red. So we're starting out positive, we're continuing to go positive, we're continuing to go positive. Oh, there's a switch. Let's record that. And then it stays negative. So the polynomial has 1 variation in sign, which means this polynomial will have 1 negative, 0, and that's it. Now remember, I'm going to keep asking you, what do you always decrease your possibilities by? And you're going to say 2. Look right here. If I tried to do 1 minus 2, I can't count the number of zeros. Remember, we are counting possible numbers of zeros here. So it is just 1 negative 0, and that's it. So let's go ahead and look at this next value down here, this next step. If we worked out the whole problem, you would find the factors are, I'm just going to show this. Let's just pretend I magically factored this, and here's what the factors are going to turn into. They are going to turn into x plus 1, 2x minus 3, x minus 3, and x minus 5. All right. Let's analyze what the real zeros are going to be because I just gave you the factors for this polynomial. So the real zeros would be, let's go ahead and list these out. Our x values are going to be, remember, -1, positive 3 halves, positive 3, and a positive 5. Now look, how many positives do you have? Here's your positive answers. You have 3 of them. Well, we knew we would have 3. Or 1. Always subtract by 2. We ended up having 3. Let's look at how many negatives we had right here. There's 1 negative, and we knew that. It is exactly 1 negative 0. Here it is. So the real zeros would be 3 positive and 1 negative 0. That is Descartes' rule of sign. It is, it's going to be a toolkit for when you go and start solving these polynomials and you just need some guidance on where to start doing your synthetic division, which we'll talk about later. So please remember, I'm going to abbreviate Descartes' rule of signs to find answers. Always. Oh, that didn't show up, did it? Hold on. Always decrease possibles, possible sign, just write possibles, by what number? 2. All right, let's do a couple more examples. Let's see what's going on here with example 1. All right, so down here with example 1, look, I have regular f of x. And what degree is this to? This is to the degree of 7. So I know for sure there's going to be 7 zeros. For sure I know there's 7 answers because that degree is 7. Some of them might be real, some of them might be imaginary. I have no idea, but I know there's a total of 7 for sure. All right, to find the possible number of positives, just count the switches in the original equation. So look, it starts out negative. Here's a switch, switches to positive. Look, it flips back to negative right here. Look, it flips back to positive right there. So how many possible positives do we have? Well, how many switches did we record? 1, 2, 3. 1, 2, 3. So we're going to have 3, or what's 3 minus 2? 1. Now let's look at the negatives. So for the negatives, I'll just do my work right here. Remember, we're going to plug in a negative x. And guys, all of the signs are going to change if they have an odd exponent. That's all you need to remember. Look, it starts out with an odd exponent. This turns into 4x to the 7. Another odd exponent. That turns into negative x to the 3rd. That is already an even exponent. It is not going to change. I'm going to copy that down exactly how it was in the original. And then plus 2, y'all, that's never going to change because it doesn't even have an x. Let's analyze the sign changes here. All right, look, this starts out positive. Here's a change. It flips to negative. It stays negative, but look, it flips back to this positive 2. How many switches did we record? 2. How many possible negatives? 2. Or what's 2 minus 2? Nothing. So it could be 2 or none. So if we factored this out, there is no way we would just get 1 negative 0. We're either going to get 2 of them or we're not going to get any at all.